this is another problem that relates to sum and difference identity. As soon as we see that minus in there, we really should be thinking, I want to use my sum or difference identity. Okay, so this kind of relates to similar to the last problem. So I'm going to see that identity. So I think, oh, right away, I'm going to go to my identity sheet. Okay, 3 pi over 2 minus x. So I'm going to use my cosine identity. It's cos. And it's minus, so I'm going to go plus sine. Okay, so when I work out that identity, well, this is an exact value, cosine of 3 pi over 2. So if I take a look at where 3 pi over 2 is, there it is there. Cosine is x, my x position is 0. Well, that's nice because I don't really need to worry about cosine x then. That just becomes 0. If I look at that same position, sine of 3 pi over 2, well, that's negative 1, that's vertical. So I end up with negative 1 times sine x. Okay, so then my identity then becomes, well, if I just simplify this, it becomes negative sine x. So what I can say is that if I take start at 3 pi over 2 and go backwards angle x, I should get the same as sine x. Well, what does that really mean? Okay, well, I can draw that out. We actually did problems like this in the circle trig unit. So I'm just going to arbitrarily draw angle x there. So there's my angle x. And then I'm going to draw 3 pi minus angle x. So 3 pi over 2 is right there. If I go backwards angle x, I'm going to get that same triangle kind of oriented in this direction. Okay, so I'm going to go backwards x. So there's my position there. Okay, so what's this question saying? It says that the horizontal position of this angle, which is right there, okay, that's going to be this length here. Okay, so I'm saying that that cosine is that horizontal length of this position of 3 pi over 2 minus x is equivalent to the vertical position of sine x. Okay, except I want the opposite. So that's negative, yeah. This is positive. I want the opposite. Well, sine is, I'll do it in blue. Okay, well, sine x is right there. Okay, there's sine x. And I want the opposite. So that's going in the positive direction. This is going in the negative direction. Yeah, sine x is positive, so I want it to go in the negative direction. So it's going to be negative sine x. Well, we can show that geometrically in that way. This is a little bit harder. So remember there's 3 perspectives: graphing, circles, and now identities. For these type of problems, whenever we have minus, we can actually now jump to these identities, these formulas, to actually work these things out. Because geometrically, some people are good with these geometric drawings, but some people have a hard time saying, well, what do you mean by sine x negative and cosine of that angle? Some people have a hard time recognizing that 3 pi over 2 minus x is that position. Okay, so the formula kind of makes it easier. So this one we did a problem like this geometrically before. There's angle x, and I'm just going to add 90 degrees to it. Okay, so I'm going to just take that angle and add 90 degrees to it. Okay, and I'm going to get this same triangle oriented slightly differently. So what this is saying is that the sine, this is the sine value of that red angle, sine of x plus pi over 2. We're seeing that that length is equivalent to the cosine of angle x. Okay, cosine of angle x is that. Well, yeah, those two lengths are exactly the same. Not only the same, but that's positive and that's also positive. It's not just the lengths are the same, but the signs are the same. So that's our geometric interpretation of this. Now we can just plug it into our identities though, and it's much easier because we just end up doing this. Well, my formula says sine x cosine of 90 degrees plus sine 90 times cosine of x, and that's equal to cosine x. Cosine of 90 is 0, so that becomes 0. Sine of 90 is 1, so we end up with cosine x equals cosine x. There's my identity proven. So this means that every time I rotate 90 degrees, I'm going to get the sine value becomes a cosine value. And this is the same thing. We've done ones like this before. I'm just going to arbitrarily draw angle x. Okay, there's my angle x. Don't draw it at 45 degrees because you lose a lot of information out of that, because we then assume symmetry, which we don't want to do. Okay, so I'm going to draw my pi minus x. Well, that's going to be right there. There's pi, and I'm going to go backwards x. Okay, so it's going to be in that position right there. So we've kind of seen this symmetry before, yeah. If I take the sine, if I go take the sine of x, I should draw this a little bit nicer, more symmetrically. Okay, so if I take the sine of x, I'm going to get the same vertical position as the sine of pi minus x. Yeah, that's true. That tells me that this formula tells me that this length is equal to this length right there. Okay, and I can show it with the formula, my formula again. This is a minus in the sine, so I go to my formula sheet, and my formula sheet says difference of sine is sine cos minus sine cos. So sine theta cos x minus sine x cos pi. Sorry, sine pi cos x minus sine x cos pi. Well, sine of pi, well, that's the horizontal position. Okay, it's right there. So the vertical position is 0, so that's all going to become 0. Cosine at that point is going to be -1. So I end up with sine x times -1, and that's equal to, on the right hand side of that expression is the sine x. Yeah, that works out. Sine x equals sine x. Okay, so using this identity for my formula sheet, anytime you see a plus or minus with angles, we always go to our identity sheet. We can show that this is always true. We saw this before with the symmetry of x compared to pi minus x. The sine values are exactly the same.